Hello there, we've got some information for you about a thing called sinusoids.
I like that. Sinusoid?
Sinusoids.
It's fun.
A function is a sinusoid if it can be written in the form f of x equals a sine of bx plus c plus d.
Right.
So definitely anything that has, or anything at least for now, that has a sine in it is a sinusoid.
Or cosine.
Well, that's what I was about to say.
Oh.
And we'll look at this a little later, but cosine and sine are so related that really cosine is just like a shift over of sine.
Or vice versa.
Or vice
but
versa.
We typically refer to it as a
Yeah.
shift of sign.
We do. We're a little biased that way, I guess.
Yeah.
But there's some things that happen with these different letters we've got here, A, B, C, and D. Like each of those has to do with a certain type of shift or stretch or shrink.
Hey, just like they were with all the other functions we've talked about to this point in time, the exact same
shifting,
kind of
thing.
Shrinking, moving happens.
So the first thing, and probably actually one of the easiest things I think with sine and cosine functions, is the amplitude of the sinusoid.
Now, here's the deal. We're going to give you a test later, and we're going to ask you for the amplitude on every single question that we put on that test. But there are only two functions that have amplitude, and only two, sine and cosine.
Technically, yeah. Only two that actually have a legitimate amplitude.
Amplitude. Amplitude is the key word here.
Amplitude is talking about how much does our graph go up and down.
Right.
From the main point. It's like sine and cosine every single time. There's like this line that they are oscillating around, right? And so in normal y equals sine x, this line that they were oscillating around was the x-axis, but that'll end up changing at some point. So amplitude is this line right here. How far are we going up, or how far are we going down? Because those should be the same. We should always go up and down the same amount.
Right.
And so if we're looking at our function here, this sine function, it turns out the absolute value of whatever a is going to give us the amplitude.
Every time.
Every single time. So for example, if we have like y equals 2 sine x, okay, that 2 that's in front, whatever number is right in front of sine,
is amplitude.
They're being multiplied together, that's amplitude.
Right.
And so when we draw this, then like instead of us going up to just 1 and down to -1, we would go up to 2 and down to -2. So that is our vertical stretch, just like when we did other
Wow, look at the
things.
green guy in there. There's a vertical stretch going on in that situation.
Do you happen to remember? I think the red function here is y equals
Looks like sine x.
And so, yes, what's going on here with this green function is our amplitude has been changed. And so this green function, it looks to me, since we still have one sine curve, one hill and one valley by 2 pi. So all that's changing is that this has an amplitude of this value up here, which is...
I believe it's 3.
That's 3. So this green function is the graph y equals 3 sine x.
Now, how hard was that?
It wasn't that bad,
No,
to be
it wasn't
honest.
bad.
No. Okay, so now the period of the sinusoid. We've talked about that sine and cosine are periodic functions.
Right.
And so the period of it is talking about how often it repeats. And we've already kind of mentioned this quite a bit so far, this particular section, that every 2 pi things are repeating. Right?
Right on schedule.
Right.
Every 2 pi.
We start here at 0 and we have one hill and one valley by 2 pi, and then it starts over and we have another hill and another valley.
So that's what you're looking for periodicity.
Periodicity, yeah, exactly.
With sine and cosine is when do you go all the way up, when do you go all the way back down, and when do you start repeating the same pattern of values. Not a specific value, but the same pattern of values.
Right. So every 2 pi. And so what happens is that they can change that on us. They can mess with the period. They can, like, look at this purple graph. This definitely goes up and then back. It has a hill and a valley way before 2 pi happens. It happens like right here at like pi over 2. It's had its whole sine curve, one sine curve by pi over 2. So what you do is whatever number's in front of x here, you do 2 pi over that, which is written right there.
Right.
2 pi over that number.
Okay, so when you're talking about period, then Just whatever that number in front of the
Right in front of x.
right in front of x.
You do
like,
2 pi divided by that,
and
that
it'll
gives
tell
you
you.
the period.
Yes, because sometimes it takes more or less time.
Right. And yes, and the reason we use 2 pi is because that's the normal period, and so what's happening here is we've got a horizontal shrink or stretch.
Right.
Because we're either accordioning out or accordioning in.
Yep.
We've got a horizontal stretch or shrink. This is really the main time that we see legit horizontal stretches and shrinks happening.
Right. Is
Every
with the
other
sine
time
and
it's
cosine
normally
functions.
vertical or
Right.
whatever. But we can stretch horizontally or shrink as well as vertically at the same time with these guys, and they're doing two completely different things.
Different, because if we were to look at a vertical or horizontal shrink with like something x squared,
Yeah, we could talk about.
You could talk about it, but you could also do it vertically. And,
Yeah.
And with the sine and cosine functions,
do
it
that.
is obvious what's going on.
It's completely different.
Yes.
Completely different situation between those two. So frequency of the sinusoid.
That's going to be like how many times it happens.
Yeah, how many sine curves do we get by 2 pi?
Yeah.
Right? And so instead of doing 2 pi over b, we do b over 2 pi. And the same thing with if it was cosine, either one of those. And the period and amplitude also would apply to cosine. Oh, wait, it says that on those. Never mind, it said that. But, so like if we
So if you look at the purple graph,
oh yeah, purple
the
graph.
frequency of this guy, if you start at 0 and go out to 2 pi, so there's 0 and there's 2 pi. Look how many bouncing up and downs we got going on.
There's 1, there's 2, there's 3, there's 4. So we get 4 sine curves by the time we get to 2 pi, which means that we have 4 over 2 pi. No, that's not it, because we don't have b. We don't have the function.
Oh,
b over 2 pi
equals 4. Yeah. B
and
over
then
2 pi
we could
equals 4.
find b if we wanted to.
Right, if we wanted to. Yeah.
Okay.
So there you go.
Let's move on to something